Let's learn numeric arrays in C. An array is a collection of elements which are of the same data type. Therefore, it's called the homogeneous data type. And these elements of the array are stored in contiguous memory locations. The advantage of using an array is we can store multiple values and still refer to all of those values using a single variable name. So using the single variable name, which is the array name, the rest of the values can be manipulated or accessed using subscripts or indices. All subscripts will always start with a 0, and using the subscripts we can refer to the elements in an array. And using loops we can traverse through an array, and arrays help in managing the memory, computer's memory efficiently. The arrays are also called static data structures because the size of the array should be known at compile time itself. The syntax of declaring an array will be the data type, the name of the array, and then in square brackets the size. So this is what was mentioned here. The size of the array should be mentioned when you write the code, that is during compile time itself. And depending upon the data type that's been declared here, the array is capable of storing elements only of that type. So A can store 10 integers only, B can store 10 floating point values, C can store values which are of type double, and this is a string which we'll be seeing in the subsequent videos. This array is capable of storing characters. Let's look at some code snippets to understand these characters or characteristics features of the array. So like I said, the declaration of a array goes like this: the data type, name of the array, in square brackets the size, and then we can terminate it with a semicolon. Now how to have values assigned to the array? Now we can have array declared and then run a loop for reading that many elements. So I have a array of size 10, so I'll have a variable k, control variable k, which will take the indices of all the elements from 0 to 9, and for those indexes I shall read the data from the user. So just before I read the data, now the elements in the array can be read only one at a time. You can't read the whole array in one go. So I have to read each element as a of k, and we know the format of the syntax of a scanf. We need to have the format specifier because it's an integer array. I mentioned the specifier %t, and each element value is going to be read using the address of operator, address of a of k. So just before the loop we could have a message, a prompt asking the user to enter elements for the array. Now the array that has been read, again for the details to be shown, now you cannot show the array wholly. I'll just tell you why. We'll have the array name displayed wholly and see the effect of that. I'll have the code run now. I am to enter these values as input. And what is being shown, this has got nothing to do with the contents of the array elements. This refers to the base address of the contiguous location. So 10 contiguous locations have been assigned to the name A, and the array name holds the base address of the whole thing, or whole contiguous location. So displaying just the array name will have the base address shown. This will not refer to the contents. So anytime you want to display the contents of the array, just like we used a loop to traverse and read elements for the array, we must have had a loop to traverse and show the contents of the array. So I have a for loop here, and within the body I'm trying to have each element displayed, probably with a space between elements, and then I'd show every a of k. So now let's re-execute the code. So I have the prompt asking for the elements. So like before, I'm having 10 elements entered. So the contents of the array has been shown like this. So anytime to read the elements for array or display the elements of the array, we have to run a loop and work with the individual elements using the subscripts. Now instead of reading the array at runtime, we can initialize the array statically, that is during compile time. One way to have this done is assigning values using the individual subscripts. So element in the 0th subscript, that is the first element, I've initialized to a 12. Element in the subscript 1, that is the second element, I've initialized to a 23. Element in the subscript 2, and so on. So this is one way to initialize data during compile time, but definitely this is not going to be easy, particularly when your array size is going to be very big. So during declaration, I could have a assignment operator, and within a set of curly brackets I can have the values assigned for my array like that. Now the size is mentioned as 10, and there are only 4 values that are assigned, so the remaining 6 values will automatically take a 0. Now to quickly have the contents shown, I have a loop to traverse and display. So when I run the code, so the 4 elements which have been initialized are displayed, and the remaining elements to make up for the size 10 will automatically be assigned with 0, initialized with zeros. Now this is one way to do. Another method of statically initializing, I can leave my array unsized. So we saw that arrays are static data structures, so definitely the size of the array should be mentioned at time of declaration. But there is a way by which I can leave it empty. In such a case, it's mandatory to have the initial values assigned. So like before, if I have a 4, 6, 8 and a 10, only 4 values assigned. Now see the effect of this code when I execute. When I have only 4 values initialized, my loop has to run to that many values only, or else it's going to pick junk from some random location and show invalid data. So the way this is to be understood is, when we have a size mentioned here, so I have a size mentioned here. Now each integer is going to occupy a certain amount of memory in the computer. So how much of memory an individual integer value will occupy, that into 10, that many bytes are going to be statically are going to be reserved as contiguous memory locations and referred to by the base address A. So if you want to see how much of memory location has been assigned, we can have an operator. So before this, I'll have the message shown here. So number of bytes or number of contiguous memory locations assigned will be equal to, we can make use of a unary operator called size of, and then mention the name of the array there. So first let's look at this display, and then look at the contents of the array. So I'm re-executing the code. So number of spaces locations assigned has been 40. So each integer is occupying 4 bytes, and therefore for 10 locations 40 bytes have been contiguously reserved, and the base address of the 40 locations is marked by or identified by the array name, that is a base address. And when we have 4 values initialized, the remaining values are going to be automatically by default initialized to a 0. But when I leave this unsized and I have only that many elements statically initialized, you have to run the loop only till that many elements. So I have 4 elements, I should run the loop only up till less than 4 for the subscripts 0, 1, 2, 3. So now when you run the code, so the number of contiguous locations are 16. So when you have an unsized array, depending upon how many values you have initialized at the time of compilation, that many contiguous locations only will be assigned to the base address, which is the array name. One more thing to be remembered about declaring an array will be the size that you mention here should be a constant. It can't be a variable whose value is read at runtime. So I can't have a value, say x, some x that's been read at runtime or initialized for that matter, even statically, it becomes still a variable. So a variable size is not allowed while you declare an array. This will throw an error. We have to be providing value which is a numerical constant. So instead of having a number, a finite number, I'm having a variable. When I run the code, that will throw an error. But what you could otherwise do is, there is this preprocessor directive hash define. What this hash define does is, just like a hash include preprocessor directive, its purpose was to include the header file that is mentioned so that you can make use of all the functionalities in the header file. There is a preprocessor directive hash define, and this hash define allows you to provide a name for a constant. So supposing I have this is not a variable, this is a name, and after leaving a space you mention the value that this name is going to refer to. So this is basically giving a name size for the value 5. So that is going to be treated as a constant. In such a case, you could have that name as your size of the array. So you can run the loop according to that size of the array. This will not throw an error. The advantage of having this is, so when you want to run the code, when you want to just check the code, there's no point of having an array size that's very big and then try to change throughout the program wherever you've given a bigger number. Supposing I had a size 100, and then for one execution I tried with 100, the next execution I want to change and try it with a 10. So wherever you put 100, you'll have to go and literally erase the 100 and type it as a 10. But when you have a statement as this, whatever size you want, a different size you want, it's just enough. At this point you go change. So my 5, if I replace it to the 10, thereafter this array is going to be working for 10 contiguous locations. I want it for a different size, then I can just change it at that point. Throughout the program, the array will be treated as 100 contiguous memory locations. So this is the advantage of having this preprocessor directive hash define. So now I have mentioned so this x is not needed. Let's get that removed. So please understand, this size is not to be treated as a variable. It's just another name. It's like an alias for a constant. So now when I run the code, the amount of contiguous memory locations, the 5 has been substituted here. So 5 into 4 individual integer values are going to take 4 bytes. So the total contiguous locations will be 20 bytes, and since I have statically initialized 4 values, for the 5th value by default a 0 will be assigned. Let's look at some sample codes. The first code is to find out the sum of odd numbers and even numbers in an array in 2 separate variables. So I have an array declared, and I have 2 accumulators, one to add up the odd numbers, one to add the even numbers. Now let's have the initial values read for the array. So using a scanf, we'll have the values read using ampersand a of k. Now when these elements are read within the array, let's now go for a loop to traverse and start checking if the element in the array is odd or even. So k less than size, k plus plus. I need to check if any a of k is a even number. So we'll enclose the condition in parenthesis. So if that condition is true, then I'll have my SE accumulator to accumulate that a of k. If in the else part, that will automatically mean it's an odd number. So I'll accumulate that array element in the other accumulator. So coming out of the whole loop, I can say sum of odd numbers, and with the placeholder I can show the value, and probably in the next line sum of even numbers, I'll have the placeholder, and for the first placeholder I will show the variable SO, and for the second placeholder SE. So that is one simple program to have the values in an array added as odd number separately, even number separately. Okay. The line terminators were missing. So let's randomly enter some values. So the odd numbers, okay, the formatting was wrong here. I must have put the equal to here. So the odd numbers have been added up and shown separately, and the even numbers have been added and shown separately. The next code we look at is to find the highest and the least value in a set of integers stored in an array. To save time, I have statically initialized the array without reading at runtime. I have variables declared to store the highest and the least in max and min respectively. For the first time, both max and min can be initialized to store the first element of the array, that is a of 0. Now I'll traverse a loop, and within the loop I shall check if any particular a of k is more than or equal to max. Now in that case I will update my max to store that a of k. I'm going to change my value of max to store this a of k. Similarly, if any value of the array is less than or equal to what is supposed to be min, then my new min is going to be this a of k. Now since this involves multiple statements, I have two if statements happening. I want both to happen throughout the loop. I definitely must have had a block here. So once this loop gets executed, and when it ends, when the control comes here at the end of the loop, I can show the highest amongst the elements in my array and display with the placeholder the value that max is storing, and I can print the least value to be what the variable min is storing. So let's execute and see. So the highest value has been 54 and the least value is a 9. The next code we'll see is to find the prime numbers in a given array. So the array is initialized with some values. I have a variable flag that is initialized to a 0, and the loop is run to traverse through the elements in the array. Now I'm going to have multiple statements typed within a block. So within the loop, for each element I have to check if there are factors other than 1 and the given number itself. So I'm going to have two more another variable declared, that is my k to traverse the outer loop, and let's say a j to traverse the inner loop. My inner loop is going to be for values j starting with a 2 until j is less than the given element and incrementing j every time. Now within the for, I need to check if a particular a of k, that is any element in the array, if it has a factor j, then it's going to be obvious that particular a of k is a composite number. So I can break the loop. Now the break is only going to come out of my inner loop. So coming out of the inner loop, the control comes to the point where the cursor is blinking because of two things. One thing is the element was a composite number, therefore on finding a factor the loop was terminated or aborted and the control came out. Or throughout the entire duration of my loop, as long as j was less than a of k, there were no factors of k, therefore the break was not encountered. So how will I know that was the case which caused my loop to end? I can check if j has reached the initial value, because the condition says as long as j is less than a of k. So once j becomes equal to a of k, the loop will end. So if that is the case, we can understand the break didn't encounter, the break was not encountered. If the break was not encountered, we can understand that a of k is a prime number. So I'll have that a of k displayed, and the loop is going to continue. Now why I had a flag here, instead of having a break, I could have checked with the flag also. I'll just show you in the next execution. Okay, the line terminator missing. So in the given set of elements, these were the prime numbers. So using the flag, instead of having a check like this, if I had wanted to use a flag, then it's important that within the loop, for every element, I have to start the flag with a 0, and once I find my factor, I will change my flag to a 1. So on finding a factor, the flag is changed to a 1, and coming out, I can check if the flag continues to be a 0, then that element is a prime number. So I'm rerunning the code, output is the same. But anytime using the break is more efficient, because on finding a factor, the loop unnecessarily need not continue to happen. So a break is a better choice than using a flag. So these codes were just a sample to understand the basics of arrays in C. If you want more codes in arrays, please do mention that in the comment section. So coming up next, we'll learn about all the sort algorithms in C, namely the bubble sort, exchange selection sort, and the insertion sort. Do subscribe for more videos.